Okay, so last time we talked about how to look at a table and come up with a limit. Well, this time we are going to talk about how to look at a graph and evaluate limits. So let me get everything pulled up here. Okay, and I just want to remind you of some of the notation that we had. Limits from the left are written with this little negative key, with this little negative symbol right there. Look at that little negative symbol. Limits, that means from the left. Limits from the right, you see a little positive symbol right above that constant that you're going to see. And the thing to remember is that whenever we evaluate limits, we're approaching an x value from the left and from the right. And in order for the limit to exist, then we have to say that the limit from the left must equal the limit from the right, and then the limit exists, and we can give that value. So those have to be the same number. Okay, so let's try a couple of these examples here. Screen went away for a second. Okay, a couple of these examples. All right, so this first example here, we have the limit as x approaches 1 from the left, limit as x approaches 1 from the right, what's the limit as x approaches 1 of f of x, and then what is f of 1. So let's try this out. Okay, so I need to approach 1 from the left. I'm going to try this one right here. Here's the number 1, and I'm going to approach 1 from the left side. So I'm going to put my pen on the graph, on the left side of the graph, and approach 1. And as I'm doing it, I'm watching what the y values are doing. And I see that right up until I get to 1, the y values are approaching that 1 right there. So the y value for where this starts is I approach this way from the left. They approach the 1. Okay? So now let's approach the x equals 1 from the right. So I jump on the right side of the graph. I'm going to approach x equals 1 from the right. And when I stop, when I get to 1, I'm at y equals 2. So the limit as x approaches 1 from the right is 2. Now, in order for the limit to exist, both this number, 1, and this number need to be the same. But I can see right now they're not the same because I have a 1 and 2. So since those numbers are not the same, then I'll say that the limit as x approaches 1 of f of x does not exist. And then sometimes you'll be asked to evaluate the value of the function. So what this is saying is when x equals 1, what's the y? Well, when x equals 1, the y value is that colored in dot right there, it's 2. Now, limits have nothing to do with the value right there. So you can just leave them as a separate idea. They do relate later on, but for right now, that's all you need to know. All right, let's try the next one. The limit as x approaches 1 from the left. So I hop on the left side of the graph. I'm going to approach 1 and see where I stop. I stop at this y value right there. So when x equals 1, the y value approaches -1. Then we will evaluate the limit as x approaches 1 from the right. So hop on the right side of the graph, trace it up until you get to 1. When I get towards x equals 1, the y values approach +1. Now, then I'm going to check to see if the limit from the left and the right, this guy, this one, come on, Pin. This is the left limit as x approaches 1 from the left and the right. Are they the same number? Well, from the left I get -1. From the right I get +1. Those are not the same, so this limit does not exist. And then f of 1, I'm going to have to erase so I can see the graph a little bit better. When x is equal to 1, y equals what number? So on the graph, when x equals 1, it's not this value because that's an open circle. We don't include that y value. Not that one. It has to be this one. So when x equals 1, y equals 0. So this is the idea that you're going to keep trying. Every time you have a graph, you're going to need to approach from the left, from the right, and see what the y values do. But I do want to show you a couple more examples. Let's see, that will look a little bit different. So let's look at this one. If I can get my pen back, I think I'm zoomed in a little too far. Okay, so in example 6 that we have here, there we go. Come on, right, there we go. Okay, I'm looking for the limit as x approaches 2 from the left. So I'm going to jump on the graph, approach x equals 2, which is right here. As the x values get closer to 2 on the x-axis, the y values are going down, 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 and actually they keep extending down. So they keep getting lower, they keep decreasing forever and ever and ever. And this dotted line means that that x equals 2 is an asymptote. So when the x values approach 2, the y values continue to decrease. So we'll say that that is negative infinity. Now, that's not an actual number, but it is specifying the direction of the graph. When x approaches 2 from the right, so I'll approach 2 from the right. Let me grab a different color here. Approach 2 from the right, so as my x values are getting closer and closer to 2 on the right, the y values tend to increase without bound, or they continue to increase. So from 2 to the right, those y values approach infinity. Now, does the limit as x approaches 2 exist? Well, are these numbers the same? Negative infinity and infinity? Nope, not the same. So again, we'll say that this limit does not exist. And then f of 2, what is the value of the y? So when x equals 2, what's the y value? Well, on the graph, there's an asymptote at x equals 2, and the graph actually never has a point when x equals 2. So we will say that that part is undefined. Okay, so then, let's see, is there anything else you might need to do? Oh yes, you're also going to have to evaluate limits as x approaches infinity. So when x approaches infinity, and when x approaches negative infinity, what I'm really asking you to do is I'm asking you for in behavior. So the limit as x approaches negative infinity of x of x. So if we say negative infinity is in that direction, as the x values get smaller and smaller and smaller, the y values are increasing. So the y values approach infinity. And the limit as x approaches positive infinity, that's over here. As the y values, as the x values get larger and larger, the y values also are increasing towards infinity. So infinity. Now, if you notice, there's not like a third line like in the previous examples on this one. It's just what's the limit as x approaches negative infinity and what's the limit as x approaches positive infinity. You won't see like what's an overall limit because we are not approaching the same number. We're approaching two different ideas. The blue one is what's approaching the left. What is the left side of the graph doing at the end? The red one is what's the graph doing at the right side. Okay, and then you're going to have a few problems like this on Delta Math. So in Delta Math, you may have already done these four where you find the limits from a table. If not, you'll just use that last video to help you do those. This video is helping you with the last four sections. So here's an example. On the first one, find limits graphically one-sided. Okay, so I have this graph, and I need to determine what is the limit as x approaches 2 from the left. So here's the number 2. And all I want to know is what's happening as x approaches 2 from the left. So I jump on the left side of the graph. And I'm looking as x approaches 2 from the left. The y values approach, stop right here, the y values approach -6. So I'll go down, I'll type in -6 and submit my answer. Oh yes, good, that's correct. Okay, then you'll have some of this, let's see, find limits graphically, type 1. All right, so now we have the graph and we need to answer all the questions below when x equals 6. So this is a graph of f, and I've got a bunch of questions. A limit from the left of x as x approaches 6 from the left, a limit as x approaches 6 from the right, a limit as x approaches 6, and f of 6. So like those paper examples we were doing earlier. So first of all, I like to go to my graph and figure out where 6 is. Okay. All right, let's do a limit as x approaches 6 from the left. So I'm on the left side of the graph. Trace it until I get to 6. That y value looks to be -3. Okay, and then 6 from the right. Get a different color here. As x approaches 6 from the right, so jump on the right side of the graph. 6. Oh, it's -1. And then the limit as x approaches 6. So this notation right here, once again, that's where you have to compare to see if the limit from the left and the limit from the right, are those the same number? If they're not the same, well, sorry, if they are the same, then that number is the limit. But if they're not the same, we'll say that the limit does not exist. And then I can erase, I need to erase what's going on here so we can answer that last question. The last question is, what is f of 6? So f of 6, I need to go and look at my graph and look where x equals 6 on the graph. Let's see. The graph doesn't have any x values where x is 6. There's nothing there. So we'll say all these are open circle. Open circle there, open circle there. So f of 6 we'll say is undefined. You'll click submit. Make sure that's what you want. And you have a correct answer. Then I'll do an example from type 2. All right, we're going to use the graph of the function below in order to determine the limit as x approaches 1 from the left. So I'm going to look at my graph. As x approaches 1, here's 1, right there. But on the graph, as x approaches 1, the y values get close to +1. So I'll say +1, submit. Yes, I want to submit. Okay, and then that last one did say I was right, but I had to stop the recording and continue it. Okay, so finally use the graph of the function f of x shown below in order to determine all values of a for which the limit as x approaches a of f of x equals 1 on the interval from -9 to 9. There are no values of a, then submit the empty set. Okay, so this means I have to find all the x values. So a is the x values. So what are the x's that give me a limit? And think of that 1 as a y. So for what x values are going to give me a limit of 1? So what I like to do, or sorry, -1. So what I like to do is I like to look at all the places on the graph here's -1, where the graph may like touch -1 or get close or approach -1. So I've got a point right here, right there I need to examine, right there, right there. And any other time the graph hits -1, ooh, this one, one's really hard to tell. Maybe I'll zoom in. Oh, no. Yeah, is that -1? Yeah, that's looking like -1 to me. Okay. So then, oh, I like that I can zoom in here. Let's look at this part right here. I'm going to check to see if the limit from the left and the limit from the right is what? Or is -1. Okay, so let's look at this first area. So as I approach the graph from the left, I get to -1. Approach the graph from the right, I get to -1. Oh, so the limit right here is equal to -1. So that x value, what's the x? That's the question, is -8. So -8 is a place where that happens. Okay. I have another place in question right here. Now, if I try to meet that from the left and then from the right, notice I have a y value of -4 here and a y value of -1 there. They're not meeting up in the same. What you want to happen is you want to draw the graph on the left, you want to draw the graph on the right, and you want them to end up in the same place. And that's how you'll know that limit exists right there. Okay, the other place where I'm seeing a y value of -1 is right here. So if I draw on the graph from the left and from the right, they both end up right there. And again, what's the x value where that happens? -4. And then let's see, there's a -1, try again, value right there. But if I try to get there from the right and from the left, see how they don't meet up in the same place? That's not an x value where the limit would exist. And then finally, we have this value right here. So if I approach from the left and approach from the right, I end up at -1, and that x value is 5. So I have 8, -4, and 5. And let's see, -8, -4, and 5. And this notation just means that you're entering separate x values. So then I'll submit my answer, check it, and it's correct. So now this should be all you need to know to be able to finish your whole assignment. Good luck, and if you have questions, you can email me or schedule a help session. Good luck, guys. See you later.